Okay, we are starting 2-1 right away. Because I'm only going to be here today.
I want to see the video, yes. Because I can gladly see it. Do you want me to show you the video?
Oh, yeah.
On the tape. Yeah, tell him to get back over there.
I agree.
It's a fan.
Put your hood up. Just sit down. Okay, so I'm only going to be here today, and then I'll be on the next week. That's why it says up here to bring your Chromebooks and headphones. But I will pretty much just be sitting on the couch recuperating, so if you guys need to send messages or emails. Is that my dog? Recuperating. No, I'm having surgery tomorrow, so I have to just like sit around for a week. Oh no. My body.
What specifically?
You guys are a little personal. No, we don't.
Can we? Is there a way possible that we can see what we got wrong in the test?
Yeah.
Today?
No.
When? Tomorrow?
We don't know yet.
Not tomorrow. That's what I'm saying.
Okay, so here's the thing. It's crazy to me that you guys are insanely interested in information about retakes and corrections, but yet only 3 people came and asked me a question before the test. I'm getting more. You're 2.
I did.
I'm getting more questions about retakes and corrections than I did about the questions in your packets. And that is absolutely backwards. We have to move at a super fast pace all year, right? Retakes are on top of all that. You don't want to do retakes. You're absolutely allowed to. You're not going to want to because it's going to suck up even more time. And while you're trying to do retakes, we're still moving on.
Not exactly retakes, but do you grade on a curve?
Still more questions after the test than before the tests.
So is that like a no?
The grade that's in there is the grade that's already done.
Okay.
So I graded it out of 39 and I gave you a free point.
That's fine.
So, retakes and corrections aren't decided because Mr. Stouffer's classes are taking the test today. They're not done. So, like, we don't decide the details of all that until everybody's done taking the test. And so, no, I most definitely can't hand it back because they're still taking it. That is a great question.
What was the question?
Thank you. So you said you're gonna be gone for the entire week. Does that mean the? Well, yeah. That's, I'm just talking. The next time when we be able to see our test, will that be when you're back?
Absolutely.
Okay. So not for another week.
Yeah, I'll be handing it back to you.
Wait, so he's not having
I'll be sending you messages about what we decide about retakes and corrections. So you guys will get your questions answered, just not right now. I get it, but I also have to talk about the information for when I'm gone. Okay, shush. You know, your question just delayed me more.
Will we have any quizzes while you're gone?
Hey, here's another great answer. I wrote it down for you.
Oh, awesome. Oh, okay.
And the electronic calendar that nobody looked at also has those same answers. Yeah, and that's fine. I don't even care if you don't look at it, then just don't ask the question about it. Okay, Unit 2. Unit 2, we are finally starting. I think you are going to find the beginning of Unit 2 relatively easy. Unit 2 ramps up towards the end of it, okay? So the idea of Unit 2, it's all about slope. And so calculus, the word calculus, is the study of rates of change. So it's the study of slopes. Unit 2 is when we start talking about slopes. So I think you're gonna find it pretty easy for a little while, because it's just ideas about slope, and you kind of already understand that. And then once we start getting into how to use those slopes in different ways, then it starts feeling more difficult. So, in terms of filling out all the notes, we are never gonna have enough time to be able to do that. But I will always go over the topics that you need to hear. There might be 2 examples on the same topic, but I'll do one of them. So I'm never going to skip a topic that you need. I'm never going to test you on a topic that I've never covered with you. So we will never finish all the notes, but that's also why I give you the completed notes, if you want to look at the things we didn't get to do. Like maybe you want to try them together. So what I wanted to start with is basically just kind of discussing slope and how it's different from pre-calc to calc. Because it is. So just given a random function. In pre-calc, you would have been asked to find, I don't know, did you guys actually end up doing slope in pre-calc?
Yeah,
I don't even know what you would use it for in there, but
A little bit.
I know you did in Algebra 2, for sure. Graphing straight lines is probably the only part you really remember about slope. So here's the first question that I get quite a bit, because in the packet and on the AP test, they don't call that a line. They call that a secant line. And so I know it says it in your packet somewhere, but I don't know where. A line between 2 points is called a secant line. What is going on with the smartboard? I give you guys pre-made notes because it's quicker for some things. But I also find it important. No, I do not mean tangent.
A different thing.
It is a different thing. A secant line is just a line between 2 points. It's probably just been referred to as a line in every class before this. Did you guys have secant in geometry? Was it a line in a circle? I mean, that sounds vaguely familiar. I feel like geometry is probably the only class that ever used that word before you learned it in pre-calc for trig. It is semi-related to trig, but not. So, if you hear it with the word line, it just means a line between 2 points. You guys remember how to find slope? Let's go with that, because that's actually kind of key.
Changing y over the changing x.
Sure. Rise over run, delta y over delta x, y2 minus y1 over x2 minus x1. I'm sure you've seen all the different versions. In calc, they traditionally just call it f of b minus f of a, which is y2 minus y1 over b minus a. They all mean the exact same thing. Well, that looked at times, but whatever. Okay, so that's regular slope. This is going to be called average slope or average rate of change. There actually is going to be a bunch of times this year where you're going to need to find normal slope. And if you ever need to find normal slope, they're going to call it average slope, or they're going to call it AROC, which is kind of annoying, but that's the acronym in the packet. Average rate of change. So, if you ever see these two terms, it just means y2 minus y1 over x2 minus x1. Okay? Now, where we move on from this where we move on from this is calculus. Wants you to find the slope of a single point. And the slope at a single point is going to be called instantaneous rate of change or instantaneous slope. So that's the instantaneous rate of change. And they generally specifically use those terms. And then I guess where we gotta go from there is we have to figure out how to find the slope from one spot instead of, from two. Anybody in here, has anybody here done this before? Let's just start that. No.
I remember hearing about that. I don't remember exactly how to do it.
Okay. Was it kind of the same thing? Was it just like at the end of the year?
No, I'm doing that right now in my PSU econ class.
Really?
It's like calc-based econ.
Oh, that's kind of rough since you haven't finished calc. How's that go?
Pretty great.
Okay. Yeah, so there's quite a few calc-based classes later on. There's usually gonna be a calc-based physics, calc-based econ, calc-based, what's the engineering one? Especially engineering. Engineering, they make you basically take calc-based everything. And it can be rough, and it feels very different. I guess what I should ask then is anybody, if I asked you to come up with an estimate of the slope at that one spot, can anybody think of how we could possibly get a good estimate? Like relatively accurate answer?
Just find the slope of the entire line.
Are you talking about the red one?
No, like the blue one, like the tangent line. Find the line of that.
Whoa, nobody even here knows tangent line yet. Where did you do that one from? From last year?
Yeah.
Oh, that's good memory. That's really good memory. Yes, that'll be an answer. In an essence of time. The way that most people usually will come up with is to just pick 2 points very close together. So, if I pick those 2 points right there, and I find the slope between them, it's gonna be a pretty good estimate of the slope at an individual spot. Now, if I back up, I guess this might be a good time to talk about tangent lines. How many other people in here did that last year already? How far did you guys get?
It's like a perpendicular.
No? Well, that's probably what you mean by it. So which class did that?
Sullivan.
So regular pre-calc? How about Sardinia? Did you guys get sort of the same spot? Flynn, did she do it last year? Okay. And then AP, I keep hearing you guys did it for a week and you don't remember it?
Yeah.
Okay.
We definitely did. But,
Yeah, right. Okay. So there is a way to visualize the slope at an individual location. When you guys were younger, you probably played with spirographs. That's what they're called. They basically looked like a gear that had a bunch of holes on it. And you would put your pencil in that gear and just like rotate it, and it would make all these shapes. And even though the shapes looked like straight lines, you would have that was a bad straight line. You would have a bunch of straight lines that made a curve. That's what a spirograph kind of draws, even though it doesn't actually draw straight lines. It looks like straight lines. Well, that's essentially what happens here. Like, if we were to draw a straight line that represented the slope at a single spot, well, I would have a straight line here, and these straight lines would just gradually change, but the straight lines I drew would make that curve exactly. And so those straight lines that we draw are tangent lines. And a tangent line, it represents the slope at a single location. And it is vaguely related to the tangent in trig. It is, I want to say geometry learns another word for or another definition for tangent, but I can't remember it off the top of my head. And yes, these are in the packet, I like to go over it differently. So, a tangent line represents the slope at a single spot. Is that written in the packet?
Yep.
I know tangent is, but it's not usually always the same definition. This is a practical definition rather than a math definition. Okay, now, you said find the slope of the tangent line, if I remember right. The problem that we're gonna have is you're generally never given a tangent line. So what we do is we find the slope at that spot, and then we can draw a tangent line that would show it. But you're generally never given a tangent line. Tangent line is just a straight line that shows the slope at that spot. Okay. Do you want me to go back to talking about taking the slope between super close points?
Yes, please.
Excellent. Let's pretend we are way zoomed into the curve. Because when you zoom in like a whole bunch of times, no matter how sharp the curve, it looks like a straight line. And we're going to pretend these points are microscopically close. What should I call that first point? A? Sure. I didn't know if you guys wanted X. Didn't know if you wanted whatever. We can go with A. We can call that Y, but since we're using A, we'll probably just call this F of A. Now this point that is super close, sometimes you're told how far away to make it close. So, like we could say, make the next point 0.01 x away, right? Like that would be a very small amount. And so I could write a plus 0.01. And then once I do that, I would plug it in and get the y value. But instead of saying 0.01 away, we're just going to say make it really close. I feel like chemistry is the one that uses the delta notation. Yes, I know, probably not everybody here is taking chemistry though, right? A bunch in it right now. So delta is going to represent a very tiny amount, a tiny change. So in some calc books, they will write delta x. Our packet, I believe, uses the h. So calc textbooks generally use one of two notations. This is one of them. So h is going to represent a really tiny number. And then what would be the height of that point? How would you find the height of that point if we had an equation? You would put that in place of x. So like if this was 2.001, you would put 2.001 in place of x. So this would be f of a plus h. The function notation definitely confuses some people sometimes. It's supposed to just mean the height. The height at a. The height at a plus h. And then if we do the slope formula, that's no different. y2 minus y1 over x2 minus x1. And then, I don't know, this probably should look vaguely familiar. I know you did it 2/3 of the way through pre-calc, but also during the limits part, I think. these cancel out. So A minus A cancels out. And you're gonna be left with f of A plus h minus f of A over h. And so this would represent the slope between the 2 points. And the reason sometimes you do this ahead of time is if you decide to make that second point 0.001 away, you could cross off h and put 0.001 in for both of them. But we're gonna pretend you guys are smart and remember limits. But that was sarcasm, obviously. Hopefully you've got that. Do you guys remember what the point of limit was for? Like, why you were taught limits in the first place? I don't know, maybe you just remember this part or something?
Did you say it was to like get us used to the idea of like infinity without like breaking us?
That is definitely true too. We don't want to break it. Limits are generally used to find an answer where you couldn't originally. So like a hole. You use a limit to find the answer of where the hole would be. So this one, the change from pre-calc to calc, is we would say let the distance between the 2 points be nothing. And then we have to be able to find that answer. So this is the beginning of unit 2. This is going to be called the derivative. Which I know is in your packet, it's on the first couple of pages. So this is the first, or I should say the next 3 months of calculus. Maybe 4 months. One idea. There's only 3 things we do in calc. Limits, derivatives, and then integrals, or sometimes people call them antiderivatives. That's the 3 topics we do in calc. It makes up 8 units. So this is what we're going to be doing, and we're going to be finding the answers to those. So now we can look at the practice. But I want to get to the example. There. Yeah, see, I labeled them, and then when they got to the printer, they didn't print the name. So I don't know, I must have to edit them differently. So here's the difference, is you actually don't need to know the individual spot to find the slope at that individual spot. You can just take an equation that you're given and find the slopes at any given spot. So we are given f of x equals x squared. What time do we get done? 24. Somebody make sure to stop me at 20 after, so I can tell you what to do while I'm done. Well, other than, just do the work, but. Okay, I'm hoping somebody wrote it down somewhere. What's the equation for the derivative?
Wait, is it the f x plus h?
Yes,
F,
forgot the first part. But you were real right with the rest.
x plus h minus f, and then x. over
H, yep, perfect. This equation is how you find the slope at any point. And not the slope between 2 points, the slope at a given point. So this is the derivative. That's what derivative means. It talks about how fast something changes. Okay, this one says use the difference quotient. That thing's called the difference quotient. Oh, that arrow is bad. No, the whole thing. The whole thing is called the difference quotient.
The whole numerator?
The whole equation.
Alright.
Well, okay, take away the limit, that's the difference quotient. Add the limit, that's the derivative. difference close, there's so many words in calc that all mean the same things. It says find the slope of the curve at 3, 9. So I want to find the slope of this equation. This is f of x. So I'm going to take f of x and put it in there. So the limit, as h approaches 0, of, actually here, I'll do this. F of x is x squared, right? X squared. That is always going to be the equation you were given. F of x is the equation you're given. How do I write f of x plus h squared? No, not squared. F of x plus h. You guys remember how to do the function notation with variables?
You just substitute like x plus h into x.
Yeah. Anything that is in the parentheses goes in place of x. In this one, you have an x in the parentheses, so you put it in place of x. If you have f of a, that would be an a. F of 3, that would be a 3. Whatever's in the parentheses, you put in place of x. Okay, so there's our limit. Now that we did the limit unit, any thoughts on how to solve that and get an answer? Because that's kind of what you're going to be faced with decisions on, is you're going to have to use all the stuff we learned in Unit 1 to do some of the problems in Unit 2.
Can we just FOIL it out?
We can try that. I mean, we can't plug in 0. I guess I should have started with that. We can't plug it in. So let's FOIL it out, see if it does anything. Do you kind of remember this from last year? Is that where you remember the FOIL it out from? Okay, that's fine if you do. X squared plus 2xh minus plus h squared minus x squared over h. These problems are basically pre-planned to work out correctly. If you do this correct, anything that's just a plain x variable will cancel. The only terms that should remain will have an h. And I'm going to guess somebody will remember what to do with that having the h at the end. So if every term has an h, I can factor it out. And this would be h times 2x plus h to the first divided by, I don't have any room. I mean, you guys, I believe, have plenty of room to write there, probably, right? I was assuming Smartboard makes it bigger. Okay, those cancel. Then I'm going to put 0 in place of what? Just h. I know you're going to be, out of habit, want to put it in place of x. You only put it in place of h. So your answer will be 2x plus 0, or 2x. And that is the correct answer. These two things are tied together. Up there, I said that equation stands for the slope at any point. 2x is going to be the slope at any point. I'll call it an x value to make it clearer. The slope at any x value on the equation we started with. Now, in the directions, it told us an x value to use, right? What was that x value? 3. We actually didn't care about the y value. At the x value of 3, I would put 3 in here. And I would have a slope of 6. I really have no room here. We were supposed to give the tangent line, right? Or did it just ask for the slope? Oh, okay. Here's the answer. The slope is 6. This tells us the slope anywhere. and we needed it at x equals 3. I think is the question below it tangent line, or is that the next page? Ah, so that's gotta be the next page. Son of a gun. I have to try to figure out how to fit that in. I need to find an equation I can do the slope of really fast. Oh, this will work. I don't need a calculator. You're not going to learn this notation yet for a couple days. Since I'm not here, I might as well show it now. F prime is going to be the equation you get when you do the derivative equation. So f prime is called the derivative, which represents the slopes of f of x. And for this equation, the derivative would be 4 minus 2x. And yeah, you'll learn how to do that quick soon. Okay, I want to write the tangent line at x equals 1. I realize this says slope of the tangent line. I want to write the tangent line at x equals 1. So first thing I need is the slope at x equals 1. The reason they write the notation like this is because now when you put a number in there, that tells somebody that you're trying to find the slope. That little apostrophe means slope at x equals 1. So I would just put 1 in. And so the slope at x equals 1 is 2. Really going back on your memory, do you remember what two things you need to have happen to write the equation of a straight line? Actually, that's not wrong, but more generic, because we're not always dealing with an intercept. So, I mean, that's correct, but you need slope and you need point. The y-intercept wasn't wrong, it's just a very specific point. So you're going to need a slope and you're going to need a point. Those two things will always give a tangent line equation. Well, what would be my point? How do we know the x value is what? They told us. On that previous problem, they told us the whole point. Sometimes they do, sometimes they don't. How do I find the y value of a point? Plug it in the original equation. So 4 minus 1, 3. Does anybody remember how to write the equation of a line with a point and a slope? It's point slope form. Do you remember point slope form? Yeah. So point slope form is actually pretty much exclusively what they use in calc. It's y minus y1. So y1 would be 3 equals m times x minus x1. Now the really nice thing about calc and the AP test, they don't make you go past there. This is actually the answer they usually look for. You don't have to turn it into slope-intercept form. The directions generally will say write the equation of a tangent line. This is the equation of a tangent line. You could change it around to slope-intercept if you want, but point slope is also an equation on its own. So this would be the equation of the tangent line at x equals 1. Oh, perfect. I got it in. Those two topics, derivative, so that's the limit as h approaches 0 of that big equation, and tangent line, those are the two topics for the first two sections. The first two sections are kind of blended together. Now, the reason I wanted to tell you what to do when I was not here is because I have it set up so that you can. The person that puts these packets together makes a video for every single section. And I honestly forgot about them, but is that something you guys would like me to post? Sure, I can post that. So if you go into Unit 2, I set up the homework, and Jean Adams is the one that created these packets, and so I put her pre-made videos in there already. I'll put the video from today in there. But tomorrow I'm expecting you guys to work on the homework together. Thursday, bring headphones so that you can watch the video on 2.2. I'll also attach my recording of 2.2 from last year if you want, because it's basically the same thing. It's the same packet and everything, so I can attach my recordings and her recordings. You guys will have all the access you will help each other out, and obviously I'm going to answer a ton of questions when I get back. My big thing is the homework that you guys are doing. Most people are not even trying to do the homework on time. I still have 1/3 of the class that hasn't turned in the homework from last chapter. There's zero reason why you did poorly on the test if you're not doing your homework. Like, I don't get you should know that correlation. If you do your homework when you're supposed to and on time, well, then you'll generally do better on the test because you know the information in each section as they build on each other. If you wait to do your homework till after the test, of course you're going to do poorly. Like, that should have been like not even something I would need to tell you. You guys are the brightest of the bright. Start being bright.
So Wednesday we're just not looking at notes, we're just doing homework.
Yeah, it's basically just alternating days between notes and homework. So we did notes today. Tomorrow you guys will be able to work on the homework through the whole hour. Thursday you'll do notes, which she goes through and fills out the packet with you. And then Friday, homework, yeah, whatever, alternating days. Okay, but either way, if you need to message me, you can. I will send a message letting you know what the retake setup is. We'll talk about it when I get back.